Hello students, I hope that you are good, well and fine. In today's session, we will be seeing equations of a line in a space. So far we have seen in this chapter three-dimensional space, three-dimensional geometry till exercise 11.1. Yes. So now we will be seeing equation of a line in a space. So as we know, as we will study that the vectors and the Cartesian equation of a line in space. A line is uniquely determined if it passes through a given point and has given direction, or it passes through two given points. Now, equation of a line through a given point and parallel to vector A given vector P. So let vector A be the position vector of the given point A with respect to the origin of the rectangular coordinate system. Let L be the line which passes through the point A and is parallel to a given vector B. Let R be the position vector of an arbitrary point P on the line segment. Then your AP vector is parallel to B vector. Yes, this means you can say that AP vector can be rewritten as lambda times some scalar times vector B. Yes, this means, but you know that AP is just nothing but position vector of P minus position vector of A. Yes, this means lambda B vector is equals to R vector minus A vector. You can see all of that information in this figure. So OA represent position vector, which is represented by small a. Small r represent P point position vectors. AP or this L line represent your line passing through A and P, and this small b vector is parallel to that. Now conversely, if you try to see that the parameter lambda, this equation gives the position vector of a P point on the line. Hence the vector equation of the line is given by this, that R vector is equals to A vector plus B vector. Sorry for this. Now remark that B vector is in its component form will be like this: AI hat plus BJ hat plus CK hat. Whereas ABC are the direction ratios of the line. Conversely, ABC are the direction ratios of a line. Then B vector will be this, and will be parallel to the line. Here, B should not be confused with magnitude of B vector. Clear? That clear? I hope that it is clear. Now we will see the Cartesian form from the vector form, so that how we can conclude our Cartesian form out of the vector form. I hope that the above thing is very clear what is happening. So R will be A plus lambda B. So this is what already written over. This sign must be not there. Here it must be lambda, not this sign. Sorry for that. This is some little error. Now I hope clear. Let us as we were here. So A is this point with direction ratios this, and the direction ratios of the line B ABC. Now consider coordinates of any point P be XYZ. Then your R will be XI plus YJ plus ZK. Where A will be X1I plus Y1J plus Z1K. Now, so position vector for P, position vector for A. Now B will be what? B will be, as the B represent the what can be taken out from the direction ratios of the line, which is B can be written as B vector as AI hat plus BJ hat plus CK hat. Substituting these values in one and equating with, the coefficient of I, J, K hat, we get X is equals to X1 plus lambda A, Y is equals to Y1 plus lambda B, Z is equals to Z1 plus lambda C. So from this you can get your parametric equation of line, where parameter will be your lambda. Clear? So this is your parametric equation of lines. Now if you want to eliminate the lambda, you can do so. You can do you will get x minus x1 divided by a, y minus y1 divided by b, z minus z1 divided by c. So this will be your what? Cartesian equation of the line. This will be your Cartesian equation of your line. Okay. Note that L, M, N are the direction cosines of the line, and the equation of the line is x minus x1 divided by L, y minus y1 divided by m, z minus z1 divided by n. Clear? Now, for example, if you are having some confusion with these all that theory, do not worry. Just try to understand by example. So let's see. So find the vector and the Cartesian equation of the line through this point is given and which is parallel to this vector. Okay. So your line is parallel to this vector as well now, and as well as the passing through this point. So this means your a small a vector will be 5i hat plus 2j hat minus 4k hat, and b vector will be this. Okay. So your r vector will be what? Your r will be what? As we have already seen that r will be a plus lambda times b. A plus lambda times b. Clear? Where a vector is coming from where? The position vector of the point given where the line is passing, and b vector is what? The parallel vector parallel to line. Okay. So you will have your answer or the vector equation as in this form, that r will be 5i hat plus 2j hat minus 4k hat plus lambda times 3i hat plus 2j hat minus 8k hat. Okay. Clear? Now r is the position vector of any point P. So this means you can write your xi hat plus yj hat plus zk hat as your r component form. Now compare, you will have the Cartesian form as x minus 5 by 3, y minus 3 by 2, and is equals to z plus 4 by minus 8. Okay. Clear? You can directly also conclude directly that how that the points given to you. So x minus 5, y minus 2, z plus 4, as you can see, and in denominator you will get what? These scalars. Okay. These scalars, as you can see. So 3, 2, minus 8. So very easy to write the Cartesian form now. Directly you can write. Now angle between two lines. So if you are provided two lines, then how you will be able to find your angle? Okay. So suppose L1, L2 be two lines passing through the origin and with the direction ratios A1, B1, C1 and A2, B2, C2 for L1 and L2 respectively. Let P be any point on L1 and Q be any point on L2. Consider the directed lines OP, OQ as given in this figure. As you can see, L1 P, L2 Q. Okay. Now, theta be acute angle, as you can see, theta be acute angle between OP and OQ. Now recall the directed line segment OP and OQ are vectors with components A1, B1, C1 and A2, B2, C2 respectively. Therefore, the angle theta between them given by cos theta, as you know. Yes, so cos theta, you will get the magnitude or the absolute value of A1, A2 plus B1, B2 plus C1, C2. Okay. Clear? Divided by root of A1, A square plus B1 square plus C1 square multiply root of A2 square plus B2 square plus C2 square. Okay. So you will get this as your, from here you can directly get your, okay, angle. Now the angle between the lines in terms of sine theta, if you want in terms of sine theta, is very simple. You know that sine square is equals to 1 minus cos square. This means sine theta will be 1 minus cos square theta. 1 minus cos theta value, you know this. So this means cos square theta will be just this. Simplified, you have this as your expression in terms of sine theta if you want in terms of sine theta. Okay, clear? Now, in case the lines L1 and L2 do not pass through the origin, we may take L1 prime and L2 prime which are parallel to L1 and L2 respectively and pass through the origin. If instead of direction ratios for the lines L1 and L2, direction cosines, namely L1, M1, N1, and for L1, and for line 2 you will have L2, M2, N2. Okay, then the angle, the cos theta will be modulus of L1 L2 plus M1 M2 plus N1 N2. Okay, what we have used? We have used L1 square plus M1 square plus N1 square is equals to 1. Also L2 square plus M2 square plus N2 square is also equals to 1. Okay, the same way you can represent the sine theta, which is root of L1 M2 minus L2 M1 whole square minus M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square. Okay, now two lines with direction ratios A1 B1 C1 and A2 B2 C2 are perpendicular. This gives you that this means theta is 90 degree, theta is 90 degree. Okay, this gives you what? Okay, so if theta is 90 degree means cos theta will be 0. Cos theta is 0 means the numerator here will be 0. Okay, so that's why it is already written over here, as you can see. Okay, if theta is parallel, if theta is 0, this means parallel. If your direction ratio, two lines with the direction ratios are parallel, this means both of the lines are parallel. This means theta will be 0. This means A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Okay, I hope that it is clear. Now if you try to see that, now if you have to find the angle between two lines when their equation are given, then if theta is acute between R, okay, then your Cartesian form, if theta is the angle between the lines, you will have what? That cos theta is equals to absolute value of B1 dot product with B2 divided by magnitude of B1 B2. This gives you x minus x1 divided by A1 is equals to y minus y1 divided by B1 is equals to z minus z1 divided by C1. And x minus x2 divided by A2 is equals to y minus y2 divided by B2 is equals to z minus z divided by C2. Okay, where A1, B1, C1 and A2, B2, C2 are the direction ratios of line 1 and line 2 respectively. Okay, clear? Now your cos theta will be what? In this form. Okay, now don't worry, just try to see examples, then you will get what we have done so far. So angle between the pairs of line given below, as you can see, are these two lines are given to you. You have to find the angle. So very easy, that here B1 is this I plus 2j plus 2k, and B2 will be 3i plus 2j plus 6k. Okay, okay. Angle, now angle will be cos theta is equals to what? Your dot product of B1 and B2 divided by magnitude, divided by their magnitude, product of their magnitude. Now you will have dot product will be what? 3 plus 4 plus 12 divided by 21 means 19 by 21. This means theta will be cos inverse 19 by 21. Yes. Now for next example, x plus 3 divided by 3 is equals to y minus 1 by 5 is equals to z plus 3 divided by 4. X plus 1 divided by 1 is equals to y minus 4 divided by 1 is equals to z minus 5 divided by 2. Pairs of line in Cartesian form. Okay, you can directly say your B1 and B2 vectors. What? B1 will be 3 5 4, 3i hat plus 5j hat plus 4k hat. B2 will be I hat plus j hat plus 2k hat. Dot product, you will get what? Just dot product means 3 multiply 1, 5 multiply 1, 4 multiply 2, add them, divided by root of square of these individual terms. Okay, then root of sum of squares of these individual terms, product them, you will apply the modulus sign, you will get your answer as 16 divided by root 50 root 6. This means in simplified form 8 multiply root 3 divided by 15. This means theta will be cos inverse of 8 root 3 divided by 50. Okay, now I have from these examples you will have some clear idea that what are we trying to do, okay, in terms of vectors or in terms of Cartesian form, how we are going to find our angle. Now next topic, that shortest distance between two lines. So how we are going to find shortest distance between two lines? So if two lines in space intersect at a point, then the shortest distance between is 0. Okay. If two lines in space are parallel, then the shortest distance between them will be the perpendicular distance, that the length of the perpendicular drawn from a point on one line onto the other line. Okay. Further, in a space there are lines which are neither intersecting nor parallel. Okay, neither intersecting nor parallel. In fact, such pair of lines are non-coplanar and are called skew lines. Okay, so skew lines are nor parallel as well as nor intersecting. For example, let us consider a room of size 132 units along. Okay, now x, y, z respectively. Okay, so 1 unit for x, 3 unit for y, and 2 unit for z. Clear? Now the line GE, as you can see, this line GE, this line GE that goes diagonally across the ceiling, and the line DB, as you can see, this DB passes through one corner of the ceiling directly above A and goes diagonally down the wall, as you can see, DB. Okay, these lines are skew because they are not parallel and also never meet. Okay, try to visualize it. Okay, the rough idea for visualization is already given to you. Now, by the shortest distance between two lines, we mean the join of a point in one line with one point on the other line, so that the length of the segment so obtained is the smallest. For skew lines, the line of the shortest distance will be perpendicular to both the lines. Okay, to both the lines. Okay, now distance between two skew lines. So in case of parallel, you can easily find. In case of intersection, you can easily answer. Now in case of skew line, we'll try to form some expression of some formula. So now consider two skew lines, L1 small L2. Okay, equation is for first A1 plus lambda B1, for second A2 plus mu B2. Okay, take S on L1 line with position vector A1 and T on L2 line with position vector A2. As you can see, these are the position vectors or the line passing through these. Okay, now then the magnitude of the shortest vector will be equal to that of the projection of ST along the direction of the line of the shortest distance. Okay, this means if PQ vector is the shortest distance between L1 and L2, if PQ, as you can see, if PQ is your shortest distance between L1 and L2, then it being perpendicular to both L1 and L2, sorry, B1 and B2. Clear? This means the unit vector n cap along PQ vector would there be what? This thing. Yes, that n cap will be what? Cross product between B1 and B2 divided by magnitude of cross product of B1 and B2. As B1 and B2 gives you what? The perpendicular vector perpendicular to what? Both B1 and B2, and dividing by its their magnitude, you will get your unit vector n cap. Okay, clear? Now this means PQ will be what? D times n cap. Okay, where D represents the distance, where D represents the magnitude of the shortest distance vector or just the distance between PQ. Yes. Now let theta be angle between ST vector and PQ vector. Then you will have PQ is equals to ST modulus cos theta. This means cos theta will be what? Just nothing but PQ dot product with ST divided by PQ, magnitude of PQ multiply magnitude of ST. PQ we know that you can write it as D n cap dot product with A2 minus A1 divided by D ST. Okay, where vector ST is just nothing but A2 minus A1. This means this can be rewritten as cross product of B1 and B2, and this is already there. Everything what we have done, we have did just nothing but use the what? N this. Okay, we have used this thing. Okay, n cap thing. Clear? Okay. Now what? Now you will have d as, so you will have d as pq is equals to st cos theta modulus of cos theta. This means d will be modulus of cross product of b1 and b2 dot product with cross product of a1, a2 and a1 divided by magnitude of b1 and b2. Okay. In vector form, in Cartesian form, the shortest distance between the line L1 is represented in this Cartesian form, L2 is represented in this way. Now the you have your distance like this. Okay, evaluating this determinant divided by this root. Okay, clear? We are not going to the derivation yet. Now distance between parallel lines. So if you have two parallel lines L1 and L2, okay, and they are coplanar, then let your lines be r is equals to a1 plus lambda b, r is equals to a2 is plus mu b, where a1 is position vector of a point s on L1 and a2 is the position vector of t on L2. As you can see this figure, L1 and L2 both are coplanar. If the foot of the perpendicular from t on the line L1 is p, then the distance between the L1 and L2 is equals to modulus of tp. Okay, this means theta. Now what? Now you can take your theta be the angle between vectors st and b. Then you will have cross product of b and st. You will have that modulus of b multiply modulus of st is equals to sine theta n cap, where n cap will be your unit vector perpendicular to the L1 and L2. Okay. Now this has, we know that, but that st vector is equals to a2 minus a1. Then you will have what? Just put here your st. You will have b cross product with a2 minus a1 is equals to what? Your b vector. Okay. Okay. Now what? Now as you can see, okay, what we have just used, that st sine theta we can replace by just pt. So you will have okay, I hope that it is clear. Now we just replace this thing. Now you will have that modulus of b cross a2 minus a1 is equals to modulus of b modulus of pt multiply 1, as the magnitude of n cap will be 1 unit vector because of the unit vector. Okay, now there must be the product sign, not comma. Now the distance will be what? D will be length of pt. This means b cross product a2 minus a1 divided by length of b. Okay, I hope that it is clear. Okay, now let's see an example so that you will have a better idea. So find the shortest distance between the lines L1 and L2 whose vector equation are given in this form, are the another line L2 given in this form. Comparing both, you will have what? You will have a1 as I plus j plus, that's it, and a2 as 2i plus j minus k, b1 as this, b2 as this, as you can see. This means a2 minus a1 will be I minus k. This means b1 cross product b2 will be this cross product between these two vectors. This means evaluating this determinant, this means b1 cross b2 will be 3i hat minus j hat minus 7k hat. Now the magnitude for b1 cross b2 will be root 59. D will be b1 cross b2 dot product with a2 minus a1 divided by b1 cross b2 is equals to what? 10 by root 59. Okay, clear? So this will be your shortest distance between the given lines. Clear? Now another example, you will have find the distance between the L1 and L2, r for L1 given in this, r for L2 given in this. Compare, just compare. You will have a1 as this, a2 as this, b1 as this, b2 as this. You have your formula, just apply. So b multiply with what? Okay, so b is what? Your this. So here both the lines are parallel. Why I am saying both the lines are parallel? As you can see, B1 and B2 both are the same. B1 and B2 both are the same. So this means that we will take the formula, we will use the formula where both the two lines are parallel to each other. This means B1 and B2 both are same. This means B1 is equals to B2. We are taking it as B is equals to this. Okay, so your formula in that case will be B cross A2 minus A1 divided by length of B. This means this will give you what? The evaluating this determinant divided by root of 4 plus 9 plus 36. This will give you root of 293 divided by 7. Okay, so this is the end for this session. Okay, next time we will be seeing NCERT exercise 11.2. okay, for now I hope that you understood. If you do not understood, don't worry, we will do enough questions, enough practice, so that you will be comfortable or you will be solving the questions by your own. So thank you. Let us meet next time again. Thank you.